Good afternoon, everybody. I'm here to bring you the story about integrated photonics. 2 years ago, I also presented it as a new era is coming, but I can actually say it is happening today. I think also Helen referred to it in her presentation, the global megatrends that are really driving change in the connected world. We can talk about AI, we can look at the 5G, but especially 6G development in infrastructure, cloud, intelligent edge, so more intelligence at the edge. Also think about point of care, gaming, visualization, simulation, and of course also precision farming are examples of what's happening. At the same time, you also look at the consumers, and we're hungry for new innovation. We're hungry of new platforms. If you see the adoption of, let's say, Facebook or Instagram, and you look at the adoption of ChatGPT and also DeepSeek. DeepSeek only took 7 days to get 100 million consumers joining and using that platform. That's tremendous, whereas Facebook took 49 months. What does it do at this moment? It's really scaling and boosting the semiconductor industry. 2 years ago, IMEC, which is the world leading research institute, presented a forecast on the market, semiconductor market, for 2026 to reach 600 billion, and for 2030 to reach 1 trillion. This year, we will pass 1.3 trillion turnover in the semiconductor industry, all majorly driven by the high-performance computing and AI. 2 years ago, smartphones were still the major consumer, let's say, of semiconductor chips. That's completely changed to the high-performance computing and AI. And it's causing challenges as well. I think there's a lot of publicity building new data centers, the power that they need, but it's also a question about the power that's available. And is this a sustainable path to continue? And for that sense, we also look at the technology. And you see that Moore's law is running out. So we cannot keep with the current progress we made in the technology. We cannot keep up with this current speed and the data growth. So we need to look for new technologies, or maybe we need to look at it at the system level. And in that sense, if you look at the system level, I think NVIDIA is a key example in it, building their hardware, is that they make use of the best chips, but they make use of the memory, the GPU, the CPU, the logic, and a photonic integrated circuit to take care of the datacom or the communication. Why do you do that? Very simple. With light, it's not only about speed, it's also the bandwidth, it's the lower energy consumption, but also the reduced signal loss and interference. And more, we're able to put optical components on the chip and therefore make the form factor very important, to make the devices smaller and therefore easier accessible also in the future for people at home, changing our lives. And there are a couple of key technologies to make that happen. And I know in Japan, also in Taiwan, we speak a lot about silicon photonics. But if you look to the strength of the Netherlands, we're particularly strong in indium phosphide and silicon nitride, two other materials. And indium phosphide is the only material where you can make an active component on the chip, in this sense, a laser. And silicon nitride is for low loss, so it's very applicable to quantum computing, AR, VR, but also in the sensing part. And what you also see is combining materials in the system, but also combining the different materials on a chip to make progress and to have the best of it to make things work. And datacom is a key driver. It's the killer app for photonic chips. This technology has been developed from the 90s, starting in Brabant from Philips and the Technical University, and it's always been a technology push, waiting for the first killer app. And AI is the killer app for photonic chip technology. But photonic chip technology can do so much more than just AI and the datacom and the communication. The measurement and detection, the sensing part is, I think, a technology that can really change our lives. With point-of-care healthcare, with wearables that can do the first diagnostics, in your body. Or in the future, you know, we don't have an expiration date on food anymore in the supermarket, but a chip will tell you if things are fresh or not fresh. That's where we're heading. And we're currently, in this case, in the first wave, but you see the potential is not only in datacom, it's also in different applications, in the security, in the robotics, in the supply chain, logistics, the healthcare biosensing and AR, and of course, what's also happening now today in the defense. So what are we, as PhotonDelta, what are we doing? So PhotonDelta is a not-for-profit growth accelerator. We're running a national program, a 1.1 billion euro program, where we try to build an ecosystem in integrated photonics. And we try to build a full value chain with being able to design, manufacture and package the chips, as well as create application companies on the demand side. So how do we do that? We offer funding for startups that are less than 5 years old. We can provide them with loans. We have subsidies that we can provide for innovation projects, where we challenge companies, universities, research technologies organizations to work together to accelerate innovation to the market. We help to build international connections. That's also why we're here today, with support also from the province and the Brabant Development Agency, and of course the embassy, because we believe we need a strong connection to Japan to overcome some of the challenges that we still see in the value chain, as well as the adoption of this new technology in certain applications. And we also help with talent, finding the right talent, because you know, we want to grow this industry and we need the right talent for that. And this is the ecosystem that we're building. So we have a full supply chain on the indium phosphide silicon nitride. We can do the design, we can do the production, we can do the packaging, testing, and we also created companies in the application domain. And I think also here you see that's not only datacom. You know, we're also looking at the sensing side of the photonic chip technology. What's possibilities in the healthcare, in the agri-food, or in the AR/VR, of course also in quantum. And more what we see, if you look to our tech partners, more and more companies from the semiconductor industry are joining our ecosystem. They have equipment from the front end and the back end that is needed to manufacture chips, but especially still for the packaging and testing of chips. If you look at photonic chip technology, 80% of the cost is still on the packaging, compared to 20% in microelectronic chips. And of course, we have a very international research partners. If you plot it on the Netherlands itself, you see that the main concentration of our industry is in Eindhoven. That's where the strength is on the indium phosphide platform, and in the east of the Netherlands on the silicon nitride. And we see a growth in the western part on the quantum computing. And we're building something new. You know, with support of the European Union, we're going to build a 6-inch indium phosphide. It says pilot plant, but it's going to be a manufacturing plant for the future. And there's a big demand for indium phosphide at this moment. And there will be a presentation later on by TNO, who's going to build and run this factory. And of course, we're here for the cooperation. And why? You know, we can look in, of course, in the research and development, where we also have some funding to support. Investor, we see also companies from Europe, also United States, Japan, taking a share into a company to be able to scale this company. Market access, I think the Netherlands is the gateway to Europe, and you can also benefit from the facilities and the infrastructure that we have to offer, but also the connectivity to the European market, as our companies are looking for an entry into the Japanese market, and supply of raw materials. And I think specifically, we can work together on the design and the manufacturing of silicon photonics and indium phosphide silicon nitride. So we don't have the silicon photonics capabilities of a foundry in the Netherlands. And also I think Europe is staying behind. So this is also where something Japan could be of interest. At the same time, we're also looking into new platforms, like thin film lithium niobate, barium titanate, and aluminum oxide, to look for their applications. Japan is very strong on the front and the back end, and that's also where we invite you to join us, and specifically on testing, advanced packaging, and heterogeneous integration. Now, if you want to know more about where we are at the ecosystem, but also where on the global side, which developments are taking place, as well as getting to know the European community, we're organizing the PIC Summit Europe on the November the 3rd and 4th in Eindhoven. It's a global event where we will have visitors from Japan. We're talking to the ministry and NIDO to get a Japanese delegation to PIC Summit. If you're interested in joining, let us know. We will have delegation from Taiwan, Singapore, India, Canada, and also speakers from all around the world, also the US, joining our event. So this is your entry, I think, to Europe and to Netherlands, and I think also in the end to Brabant. Thank you very much for your attention, and happy to build the future together with you. Thank you.